Activity 2B dealt with longitudinal waves, which longitudinal waves are sound waves. That's the way sound travels from one place to another. So a longitudinal wave, the particles of the medium are displaced in direction parallel to the medium. So if the wave is moving this way, then everything's moving this way. All the energy's moving. The particles that are being displaced are moving along the same line. So you can see the parts of the wave here. The parts of a wave, you have compressions and rarefactions. The compressions are the areas where the waves are bunched, or the particles are bunched together. The rarefactions are the areas where the particles are spread apart. So you can see that in the picture of the slinky, how the particles are far apart. So to measure the amplitude, you can measure amplitude in compressional waves also. You measure the width of a compression. And then a wavelength is, you can do it a couple of ways. You can do the beginning of a compression, as in this diagram, the beginning of a compression to the beginning of the next compression. A lot of times students like to go from the middle of a compression to the middle of a compression, because those are pretty obvious points. So for part 2, you were just going to identify parts of a wave. So the rarefactions, and the rarefactions are the parts that were spread out, So the rarefactions would be B, D, and F. So these are the parts where the molecules would be spread out. So B, D, and F. So that would be D. The compressions are the parts of a longitudinal wave where the molecules are pushed together. So you're looking for bunched up areas where they're bunched up. So that would be E, C, and A. So E, C, and A would be choice C. And then it asks you to indicate the interval which represents one full wavelength in the diagram. So we have answered those. So you're looking for light point to light point. So it could be A to C. It could be C to E. So A to C would be our choice there. So then you were asked to identify, count compressions, count rarefactions, measure amplitude, measure wavelength, and then do some calculations figuring out the frequency and then the wave speed. So the first thing in this, you were asked to count the number of compressions, so the bunched areas. So that's 1, 2, 3, 4, 5, and then 6. So 6 compressions. Number of rarefactions. Okay, so the rarefactions spread out part. So this part in here. So that's 1, 2, 3, 4, and 5. So we would put our 5 for number of rarefactions. So for the amplitude, you measure the width of a compression. So you would measure the distance from one end of the compression to the other. And this one I think is probably about 1.5 centimeters. Okay, and then wavelength is, the most obvious would be the middle of a compression to the middle of a compression. And it's probably about 4 centimeters. Okay, number of waves. So you're going to count the total number of waves. So the easiest way is to go from a compression to a compression. So from here to here, that would be 1. And then from that compression to the next compression would be 2. This compression to the next, 3, 4, and then 5. So total number of waves would be And again, we're assuming that this is a picture of a 1/10 of a second in time. So there are 5 waves in a 1/10 of a second. So to get the frequency, which is how many waves per second, we would multiply by 10. Okay, because there are 10 tenths in a second. So 5 times 10 would be 50. All right, and then just like with the transverse wave, to find the wave speed, you multiply frequency times wavelength. So you take your frequency of 50 hertz, and then you're going to multiply that by your wavelength of 4 centimeters. So 50 times 4 be 200, and it's going to be 200 centimeters per second, and that would be the wave speed for this particular wave. You have 3 other waves to do, B, C, and D. Do them the same way and do your same calculations. Again, just practice counting and measuring waves. So this culminated with question 32. It asks you to look at the 2 waves and which wave has the greatest wavelength. So you're going to look, wavelength, remember, is compression to compression. So for wave A, it's going to be, the wavelength is going to look like this. For wave B, the wavelength is going to look like this. So the greatest wavelength is going to be the longest, so it's going to be wave B.